So, chapter 17 is all about the solar system, and we're actually going to do two sections in one because we're on a time crunch. So, we're going to do 17.1 and 17.2 today. It's a lot of material. It's probably longer than our usual lectures. I apologize for that, but we're trying to get a lot in here. So, astronomy is really something, it's one of those fields of science that people have been really tuned into since the beginning of time. You got to think about early on, what people had in their lives. The stars were sort of entertainment to them. It was something um, that was really obvious in their daily lives. And we're not going to get into it in this section, but one of those first things they made a connection with were what we call constellations. So looking up at the sky, seeing the patterns in the stars in the sky. Maybe they look like a person, maybe they look like an animal, and that's what constellations are. Um, these things also led to them looking at certain, we'll put in quotes, stars and noticing, hey, they do a little bit different things than the other stars are doing. We notice that they're moving more in the sky. And that is what they later found out were actually planets. Planets comes from the Greek word meaning wandering star. So early on, we could see these things. Even to this day, probably one of the most um, obvious things we see in the sky is Venus at nighttime and in the morning. Looks like a star, but it's actually a planet. So astronomy is the study of celestial objects and their phenomena. So now think of everything beyond Earth, um, beyond our atmosphere, essentially everything. And it's not even just everything in our solar system, it's everything beyond our solar system. So much history regarding astronomy. Galileo is probably one of the people that had many of the early notable real scientific discoveries in terms of astronomy. Just to mention a few here that your book talks about, he was the first person to actually notice that Venus goes through phases. Early on, one thing that people thought is they actually thought that the Earth was at the center of the solar system. So I'll say that again. They thought the Earth was at the center of the solar system. And it was very controversial because of how affluent religion was at the time for someone to come out and say, no, it's not the Earth in the middle, it's the sun, because we needed to be this all-knowing, all-being entity that had to be the center of everything. So Galileo kind of came out and said this, did not go over very well. He also discovered the four largest moons of Jupiter, and to this day they're called the Galilean moons. Galileo's discoveries, this is just a few, he had many discoveries help prove that Earth and the other planets orbit the sun, disproving the early theory that the Earth was the center of the universe. So he kind of came up with the factual information saying, hey, we think this is what's happening, but here I'm actually providing you with evidence that yes, the sun is at the center of the solar system. So what is the solar system? It's the sun and all the objects that are gravitationally bound to the sun. So we think of the solar system just as planets, which they are. We have our two different sets of planets, and we're going to talk about those today, inner planets and outer planets. But we're also going to learn in the next section how there are other things in our solar system. It's not just planets. We have other things inside there. So we have our inner planets, Mercury, Venus, Earth, and Mars. And then our outer planets, Jupiter, Saturn, Uranus, and Neptune. And then we also have the recently awarded Pluto, which is the dwarf planet. So inner solar system, outer solar system, those things are part of our solar system, but like I said, they are not the only thing in our solar system. Gravity plays a huge role when we talk about astronomy. Gravity is a force between two objects, and it depends on two factors, mass and distance. And that is, it was discovered by Newton. That's why it's called Newton's law of universal gravitation. He actually has a mathematical formula set up for you to figure it out. We're not going to get into that in 8th grade science. But no, obviously, when you look at the two things I have in caps lock there, mass and distance, those two things play a big role in that universal law of gravitation. Really what that's saying, anything in the universe, doesn't matter if it's you, the planet Pluto, you and maybe an asteroid in the asteroid belt, there is honestly gravitational pull between everything. So if anything has matter, it is going to have a gravitational pull with anything else that has matter. Now, why don't you pull yourself towards Pluto? Why do you stay here on Earth? Because remember, gravity depends on two things, mass and distance. So what that means is the larger something is, the stronger the gravitational force. Distance, the closer two things are, the stronger the gravitational force. It's the reason why the moon stays in orbit around the Earth. and it does an orbit around the sun. While the sun is huge and has much greater mass, the moon is closer to the earth, so it's going to stay in our gravitational pull. So gravity depends on mass and distance. The more mass, stronger the gravity. The closer two things are, stronger the gravity. Orbit, the path of a celestial body around another body. So Earth has an orbit around the sun, and as we all know, it takes it about 365 days. The moon has an orbit around the Earth, takes about 30 days. So that's what an orbit is. It's kind of like the path, the raceway that these celestial bodies take around something else. So it's a regular repeating path that an object in space follows around another object. When something rotates around something else, we call it a satellite. So a smaller object that orbits a larger object is called a satellite. So yes, we have human-made satellites that we put up into space. Yeah, they're satellites. But also, if you look at this definition, excuse me, this also means that the moon is a satellite, which it is, because the moon orbits around the Earth. So an orbit results from the balance between two things, inertia and gravity. So inertia is momentum that an object has. So it's kind of like when you're in a sled and you're going down a hill, you've got inertia. You are moving, and Earth as a celestial body has inertia. We are moving through space at a very rapid rate. So not only are we moving, at the exact same time, the sun's gravitational force is pulling on us as well. So those two things together actually keep us in our orbit. If you look at this picture here, I love these pictures. Imagine removing one of these two things. So imagine removing inertia. So you no longer have the motion of Earth moving. It's almost like when you take a baseball, you throw it through the air, you're giving it inertia. If you remove that movement, gravity is going to win out and it's just going to get pulled right into the sun. On the other hand, you remove gravity, think of that. Now what's going to happen? You're going to go flying off into space. So what actually happens is because you have gravity pulling towards the sun and inertia moving in a straight line, the celestial body splits the difference, goes at a 45 degree, and now you can see why it stays in that orbit. So those two things, inertia and gravity, keep objects in orbit. You need both of them. You can't just have one, because if you just have one, it's going to win out and it's going to do its thing. Now, when we talk about orbits of planets, or even if we talk about orbits of moons or orbits of comets, which we'll talk about later on, all orbits are what we call elliptical, or they follow a shape called an ellipse. So they're not circular. They're actually, think of it this way, more squashed a little bit. So what happens because of that is not everything is directly in the center that it's orbiting it around. So what that would mean is when you look at our planet orbiting the sun, as you can see just even in the red line there's going to be times when we're closer and there's times when we're farther away. Shockingly, we talked about this with these seasons a little bit, we are going to be closer to the sun actually in December, and we are farthest away in the summertime. So elliptical, we are not right in a circle. Not only are these planets moving in an orbit around the sun, we are also rotating on an axis, so spinning. So just like a globe, think of it that way, where you are spinning on an axis. So an axis is an imaginary line that passes through the center of a planet from pole to pole. So on Earth, our rotation, or our axis, is tipped at about 23.5 degrees. It doesn't always stay that way. It actually wobbles a little bit, which causes some climate effects, but it is tipped about 23 degrees. In this picture, as we see on the side here, one rotation on our axis, one spin, takes us 24 hours. So it's really important to remember, not only are we moving in this orbit around the sun, we're spinning at the exact same time. And these two things give us the things that we see on Earth here, like differences in sunlight, differences in temperature, and those things can affect life on Earth here. Now, when we start to talk about the solar system and in space, we are talking about such a large, massive thing that they came up with different units. If we were to use like the mile or the kilometer, way too small. So what they came up with, one of the terms that we use is called an astronomical unit, or it's abbreviated AU. It's about 150 million kilometers, or it's about the distance from the Earth to the sun. It's our average distance. So Earth is 1 AU from the sun, Whereas you look at a planet like Mercury, Mercury is 0.39 AU from the sun. So just by looking at that number, you can see it must be closer to the sun than we are. When you start to get even bigger, when you look at things farther away from us, now we're starting to talk about light years. So space is so vast that we now use how fast light travels or how far light travels in a certain amount of time. And as we all know, if you've ever turned a light switch on in a room before, light travels really, really fast. So 1 astronomical unit is the average distance from us to the sun. So Earth to the sun. Neptune, for example, look at that, 30 AU. So it's 30 times far away from the Earth, from the sun than the Earth is. That's crazy. That's a really, really, really big number. All right, so now on to the planets. We're going to go through these quickly, but that's all right. You guys are going to be doing a little project on it. So there is our 8 planets. We used to use, my very educated mother just served us 9 pizzas, but now we don't have that anymore. I feel like there's another one, but my 12-year-old brain cannot get that out of my brain. So my very educated mother just served us 9 pizzas and pretend we're forgetting the pizzas. All right, so our different planets, you can see, look at this picture. Do you see a vast difference between the 4 inner planets and the 4 outer planets? There's a big difference. 4 inner planets are what we call terrestrial planets. Terra means land. These planets are rocky. They're actually more dense than the outer planets. And as you can see, they are much smaller. So that is Mercury, Venus, Earth, and Mars. And then the 4 outer planets are what we call the gas giants. They are primarily made up of gases. That's why they're called the gas giants, and they are huge. That's why they're called the gas giants. Jupiter, Saturn, Uranus, and Neptune, they are much less dense than the terrestrial planets because they are primarily made of gas. And all of them have many, many more moons than the terrestrial planets. Mercury, for example, no moons. Venus, no moons. Earth, hopefully all know we have 1. Mars has 2. Those outer planets did not really have to compete with the gravitational pull of the sun like the inner planets did, so they were able to hang on to a little bit more debris. So we're going to do really quick versions of these planets. Mercury, named after the messenger god, and that's because Mercury goes really fast around the sun. It only takes Mercury, look at this, 88 Earth days to make 1 trip around the sun. So if you were on Mercury, think of how much older you would be, kind of multiply your age by 3, that would be about your age on the planet Mercury. So closest planet to the sun, it's actually the 2nd smallest. If we count Pluto, if we don't, it's going to be the smallest planet in the solar system. Temperature varies greatly. Mercury doesn't have a really strong atmosphere, and because it doesn't rotate quickly, if you look at the length of day here, a length of day on Mercury is about the exact same amount of time as a year is. So when you look at a planet that does not rotate very quickly at all, what happens is one side gets crazy hot and one side is really cold. I always like to use the analogy of it's like you throw a burger on the grill and you never flip it. That one side is going to be super charred, and then the back side is not going to really be cooked at all. That's kind of Mercury. So rotating slowly, and so one side gets really hot, the other side gets really cold. Look at that temperature difference there, big temperature difference. Right, so Mercury, fast messenger god. Venus, goddess of love, but not so much when you actually really get to know the planet Venus. Venus is also called Earth's twin. As you can see in the picture here why that is. It's similar in size, however, most similarities end after that. Venus is the brightest planet in the evening sky and in the morning sky. That's why it's also called the morning star and the evening star, even though it's not a star, but it's really bright outside most of the time. It's not that far off the horizon. You can see it super, super bright. Venus's claim to fame is it is the hottest planet in the solar system. If you look at the temperature here, 460 degrees Celsius. Venus's atmosphere is primarily carbon dioxide, 96% carbon dioxide. Carbon dioxide is a greenhouse gas that traps heat. If you have an atmosphere that is containing a compound that essentially traps heat, no wonder why it is so hot on that planet. Really hostile environment. Not a lot can survive there. So even some of the probes that we have sent there, they don't last very long. It also rains sulfuric acid on the planet Venus. So yeah, you can see how it's really, we named it after the goddess of love. It is definitely not lovely on the planet Venus. Earth, we know Earth, right? We live here. We've got life. That's our claim to fame in the solar system. We are a rocky planet. We have a great atmosphere that you guys have learned about this year that does wonderful things for our temperature. We have water, which does wonderful things for life, to sustain life on Earth. And as we all know, length of day is 24 hours, and we all know how long a year is, 365.25 days. I may be impartial, but I think we're the prettiest. All right, Mars, fourth planet from the sun. Fourth planet, it is the red planet. The reason it is red is because it contains iron on the surface. And just like around us for up here, we have a lot of red dirt because we live on the iron range. All of the red in the dirt of Mars causes it to be red in color. This would be the one planet if you're looking at, hey, where are we going to colonize in the solar system? Probably going to be Mars. It's cold there, so average surface temperature -50. Atmosphere is very thin, a little bit higher amounts of carbon dioxide, but it's doable. Like it's something where if you've seen the movies and they've set the stuff up, you know, a little place for you to be, it could happen. Length of year 687 Earth days, so really a long period of time. Mars is named after the Roman god of war. Mars has 2 moons, which we think are possibly captured asteroids from the nearby asteroid belt. They're not spherical in shape. Cool thing about their name is they are named Phobos and Deimos, which the god of war, Mars, rode around on a chariot, and his 2 horses that pulled him were actually Phobos and Deimos. So it's pretty cool. Mars, red planet. Very well known for Olympus Mons, massive, large, geological feature on its surface. After we move through the asteroid belt, which I didn't include on here, but the asteroid belt is a place where we have lots of asteroids in the solar system. Then we move on to the largest planet in the solar system, and that is Jupiter. Named after the king of the Roman gods, it only makes sense that the largest planet in the solar system is named after the king of the Roman gods. Made of gases, primarily hydrogen and helium. In some ways, it's actually more like a star, no joke, than a planet. Its mass is greater than the combined mass of all other planets. One of its most notable features is what's called the Great Red Spot. It's a giant windstorm that has been on the surface of Venus where you could fit like 30 Earths inside of it, to give you an idea of just how large the Great Red Spot is. Lots of moons. This particular slide says 63. But you can go elsewhere and find different numbers based on what criteria they're using for moons. So that number might be a little bit different. Jupiter's almost like its own little mini solar system. Then we move on to Saturn, the second largest planet. It is probably most well known for its beautiful ring system, but another fun fact that I didn't include yet is all of the planets, the gas giants, technically have ring systems. Saturn's is just the most predominant, and we can see it the most evident, so it sort of gets that claim to fame. Another fun fact about Saturn, its density is less than 1, so technically speaking, if you had a bathtub big enough, Saturn would actually float in it. Named after the Roman god of agriculture and time, and you can kind of see why when you look at the picture there. Length of year on Saturn, 29.5 Earth years. So if you lived on the planet Saturn, you guys would not have even had a birthday yet. I would have had a birthday, just one. I'd be one, but yeah, you wouldn't even be one yet. Pretty cool. Saturn, known for its ring system. Uranus, another gas giant, 7th planet from the sun, rotate on its side. That's a fun fact about it. So imagine like how ours is tipped at a 23.5 degrees. No, completely tip it on its side. And that is actually how Uranus rotates. It is the coldest planet in the solar system. Average temperature, as you can see there, is minus 197 degrees Celsius. It's named after the first Roman god. It has about 27 moons, but just like any of the other gas giants, that number can change a little bit. Uranus's moons are all named after characters in Shakespearean plays like Ophelia and Puck. If you enjoy mythology, you would enjoy astronomy. There's so many connections between mythology and astronomy. Neptune, 8th planet from the sun, outermost of the gas giants. It is the stormiest of all the planets. It gets its beautiful blue color from methane gas that's in the atmosphere. It has less moons than our other gas giants, as you can see here, about 8 moons. Still really cold. You got to start thinking about, we are so far away from the sun now that a very low amount of sunlight gets there. So you're not getting that solar radiation like we are being close to the sun. Length of year, 165 Earth years. So no human being has ever survived being on planet Earth while Neptune took a full trip around the sun. 165 Earth years. Neptune was named after the Roman god of the deep sea, and all of its moons are named after mer people, so famous mythological mermaids or mermen. So Uranus and Neptune very similar to each other in color. So overall, you guys should just be kind of noting big difference between these inner planets, Mercury, Venus, Earth, and Mars, and our gas giant outer planets, Jupiter, Saturn, Uranus, and Neptune. I wish we had more time to talk about them because they really are cool. You're going to be picking one of these now and then kind of using that to make a flyer thing that we're going to do in class. But super cool, love planets, awesome.